Okay, ladies and gentlemen, good to have you here today. A minute ago, Gavin answered my question, which was, in this problem here, what are going to be the units of the answer? And the answer is going to be tons, okay, because we're given rate pollutants in tons per month. Now, typically, in this type of problem, where it says showing the rate, so it doesn't have, I guess it's the beginning, so an estimate
Oh, I remember this.
of, now remember what goes here?
From 0 to 9.
0 to 9,
Wow.
and then we're not given a equation right here,
Oh,
but you can call it like, we'll call it T tons per month. So tons,
What?
TFT DTs we'll call it. That'll be your tons per month DT. And so that'll be it. And then our estimate. Now what you're going to have a lot of times in like tests, you'll have sometime an initial amount. So sometimes what they'll do is they'll ask for what is the amount of tons, and we started out with so many tons. So if we started out with 5 tons, the answer would be 5 plus this thing right here. So you just have to watch out for the language of that. And now what we do is we look at the number of intervals, and how many intervals do we have here? 6. So we have, what you got to do is the bridge. 1, 2, 3, 4, 5, 6. Looks like 6 intervals, right? Equals, and we're just going to go ahead and put 6 things right here. And then Gavin's going to give us the units again, which are tons, right?
Wow.
So that's our tons. And now we have is what a trapezoid is. And yesterday in class, Aaron was kind enough to give us the area of a trapezoid, which is going to be 1/2 of base 1 plus base 2 times the height. And so you'll see it written in different forms.
oh,
But
I remember that.
what's going to happen is what I like to do with this is when I fill out the blanks, the first thing I do is I go like this. And the next thing I do is I put down the width, or the height of each trapezoid. What's the height of each trapezoid? 1,
Oh, because it's going
2,
1, 2, 1, 2.
welcome to room 15, where learning comes first. Noah? No, Noah is not in this class. Somebody came looking for a Noah here, and there's not a Noah in this classroom. No, I do not have a Noah on my rolls this year. Okay, 1, and what's this one here?
2.
2,
And then 1, and then 2.
1, and 2. And so now is where the base 1, base 2 comes into play. And what I'm going to do is I'm going to run out of writing room.
Yeah, I did not need a bunch of room.
And so what I'm going to do to help me out with this is just my pen thickness. That's going to help me a lot here. So here, these will be your base 1, base 2 right here. So you have 5 plus 7. And this next one here is going to be 7 plus 8.
Oh.
The next one here is going to be 8 plus 10. So you just kind of go down the list here. 10 plus 13. 13 plus 16. And finally, you have 16 plus 20.
All divided by 2?
Yeah, because this is part of the formula, right? So everything is here.
Oh.
Here are the heights. 1, 2, 1, 2, 1, 2. And then divided by 2. And so you have it right there. And you can go ahead and using simple arithmetic, you can simplify all those and condense everything into a single numerical answer, right? But do we have to do that? No, we don't have to do that.
So that's the trapezoid thing? You just-
That's the trapezoidal rule.
It doesn't seem too hard. I bet I can catch up.
Yeah, that's right. We just started it yesterday.
So
We
we
just
did
did
one
it,
for
yeah,
now?
we just started at the very end of class with like, what, 3 minutes of class? With 3 minutes of class, what we did is in fact, if you go watch the video from yesterday's class, the last 3 minutes, you'll see us talking about this one here. Okay? That's not too bad, is it? Okay, what I want you to do is, we have this problem here that's kind of a little bit of a halfway interesting problem. It's the bug crawling problem. And so the bug is crawling at this velocity, and so find the distance the bug crawls during this hour using 10-minute increments. Let's go ahead and see if you can construct
10 minutes.
that. In fact, what I want you to do for that is, probably make a table, and you could do, you want to do different ways of doing it. You want to do trapezoidal rule. Okay, you guys. Okay, you guys are my trapezoid people. You guys here are my right Riemann sum, and that'd be Carson too. So I want you to do right Riemann sums, and I want you two to do trapezoids.
How many 10-minute increments are now? 10? Oh, 10, 6. 10 minute increments. I'm stupid.
Good
Sorry,
work.
did you? Don't think doing lots of you.
Good. And while you do that, I'm going to do functions.
Wow, I do not know how to write numbers.
You don't know how to write numbers?
Yeah. My zeros look like sixes.
I wrote 13 really close together for the one above this one, and it looks like B.
Oh, let's see here.
It looks like B plus 16.
There's no room.
Whoa,
There's
what
no
the
room,
heck,
okay.
Mr. G? This is goofy.
It is goofy.
You gotta like deal with fractions?
I don't like fractions. I don't like it.
Can we switch parts?
Oh, where T is in hours.
Oh.
Oh.
Yeah. T is an
Oh, well,
L.
that makes it even more complicated.
T's an hour, so we went 10-minute increments.
Oh, so basically what you're talking about is
Will you help us with the table, and then we'll figure it out the rest?
is 1/6 of an hour.
Carson, we were waiting
Before you
so
do
long, we're in a group again.
Yeah. We're in
So,
groups again.
Yeah, so not
T
moving.
equals, oh boy.
So you do it since you were the last year, and me and Matt and Ari did
Oh.
those together.
Oh,
This is a nightmare.
oh boy. You should help us with the table, and then we can sort of enter our group.
I know what the real answer is going to be. Okay, let's look at this.
Fine. World. Oh,
Okay, look at this. There's a table, and this will apply for you guys too, right? So you have between T, so you have, what you're going to have is, in meters, find during 10-minute increments. So what you have for your increments, you're going to have 1/6 of an hour, right? Is that right?
Yeah.
1/6 of an hour. So let's do this. We'll have T here, and we'll have V of T right here. And we're going to start out at time equals 0, and you can plug in 0, right?
I like it, yeah.
So, so 0
Oh, but that was it.
is, and so we have 1/6, or it's 1/2, 1/6, right? And then t equals the next sixth after that, that's gonna be 1/3, right? I'll put 2/6 just to make it
Oh, you're killing me.
3/6 of an hour, 4/6, and then 5/6,
And 1.
and then
6/6.
1, or 6/6, yeah, or 1, right? And so now, if we plug in 0, what do we get? 1/1, right? So that's going to be our velocity there. And then if we plug in 1/6, what we get is for 1/6, we get v equals 1, and then we have 6/6 plus 1/6, right?
7/6,
Which equals 7/6.
which is 6/7.
And then we have 1 divided by 7/6 is going to be 6/7.
I knew it.
So this is going to be 6/7 here.
Wait a second. 6, 7.
So
Because
see,
it's 1 divided by 7/6.
1 divided by 7/6.
So you just multiply by the
So we just, what you do is you're dividing by a fraction, so multiply by the reciprocal. So we get 6/7. And then you plug in for the next one. For next one, you can plug in 1/3. So you have v equals 1 over 1 plus 1/3, right? So that's going to be 4/3.
Which is going to be 3/4.
So you go about, so 3/4. And so you go about,
3, 6, that's just 1/2, right?
yeah, that's 1/2.
Which is just me 2.
Well, it's,
No, it's not. I'm dumb. Sorry, Mr. G. Ignore that one. No, just
so you have 2,
just 3,
Be 2/3.
2/3.
yeah, 2/3. So this one will be 2/3 here. So you get the idea, right? You can just go, and so is the bug slowing down?
Yes.
Yeah, bug is kind of gradually slowing down. And I know this last one here is going to be just 1/2, right?
But what's 4/6?
6 times.
Oh, duh. Or 3/5. It's 3/5. And then 6/5. You know it?
And this one here, you get 2/3.
That'd be 11/6. Oh, that'd just be like 6/11. That's gross.
So 1 over 1 plus 2/3 is going to be 1 over
Wait.
5/3,
You get that.
which equals 3/5.
Yup.
So this is 3/5 here, and this one here.
You can do it, Hannah. I believe in you. No, no, no. Careful.
And this one here would be 5/6, 1 over 5/6 plus 6/6, which equals 1 over 11.
Ew.
So 6/11. Or 6/11.
6/11. 5/6 plus 6/6. That'd be 11/6, right? Then 6/11s, you're right. So
Oh,
really,
man,
so
I
this is,
Are there 6 intervals again?
I mean, the only thing that's going to save you on this one here
There are 6
is
intervals.
you don't have to, you just have to write out the relationship. You don't have to go ahead and do the, calculate what it is, right? You have everything you need to do over here. your right Riemann sum. You have everything you need to do a right Riemann sum, right?
You're doing the trapezoid?
And you have everything you need to do the trapezoid.
Oh, but the height is 1/6. Oh, that's goofy.
Yeah, the height of these,
So really, it's everything is over 12 instead.
1/6, yeah.
So you have to just
So
add-
everything's over 12?
Yeah, since it's 1/6, you can just multiply the two. How sneaky is that? And then it's just the width of the bases.
Yeah, so you have, for your trapezoid people, you're gonna have like, your height of all these is gonna be 1/6. And the height of the trapezoid is gonna be the same as the width of your the height of your trapezoid is going to be the same as the width of your what? The width of your what the Riemann sum? What geometric shape do you use to get Riemann sums?
Rectangle.
A rectangle. Thank you.
Boom, done.
Yes.
Can't really tell what I wrote
You owe me
down.
one. Take the fat back.
I even used my,
I'll eat five, I'll eat a dollar.
Okay.
No.
So what I have here, I'm going to show you what I
You owe me a dollar.
I don't know how far you guys are. You still working on that hand? It looks like you are. This is what I had from a prior
the white one.
year on this.
No, nothing like
This one right here.
Twist it.
And this one here, what type of
Pop it.
thing did we use here? A left Riemann sum is going to give you this.
that doesn't look right.
Okay, you get that. But your real answer, if you use the equation in your calculator, you get this. So that's going to be.
What do trapezoids give you? I almost want to.
Yeah, so it'd be interesting. You use trapezoids. What you're going to get probably a pretty close to the exact answer on that, but it'll be just a lot of calculations to that.
A lot of calculations because right now.
Yeah, because there'll be a lot
Pretty goofy.
of things. Of course, this is the left Riemann sum, and you guys
I'm doing the right. Why are you telling me?
is what's going to give you a higher estimate value, a left Riemann sum or a right Riemann sum?
I'm not pretending.
Oh, but okay, there's a 50-50 guess right now.
When?
Okay, Gavin is 100% right. Gavin is, why is left Riemann sum going to give you a higher value?
I don't remember, but you said something a minute ago that.
Okay, that's right. That's right. Because the function is decreasing, right? And when the function is decreasing, left will give you a higher value. Okay, so Gavin's remembrance is really good. But another thing is the rectangles are going to be higher when you go to the left. See, these are decreasing. So if you use the left Riemann sum, your rectangles are going to be bigger.
Yes.
And so that's why you get a higher
You're
value.
asking USA.
So you got a higher value here than
The green.
this right here is the real value for the calculator. So that's the calculator right here. So let's go on here, erase this piece first. I just thought that problem was kind of a little bit interesting.
I thought it was cool.
Yeah,
I like
a
bugs.
little bit interesting.
You like bugs?
Yeah, I'm afraid of ladybugs. Don't even get me started.
Okay, here we have another one
Ladybugs are monsters.
where object has zero initial velocity and a constant acceleration of 32 feet per second squared. Complete the chart to find the velocity at these specified times. 32 feet per second squared at a constant acceleration. So after 1 second, so you have your 32 feet per second squared. So what's going to be your velocity after What's going to be your velocity at time equals 0 if you drop it, right? 0 initial velocity, right? So what are your velocities going to be here and here and here?
25 squared.
What are you doing, 0.5?
I don't know, because that's the next one.
But it's acceleration, you need to put it into the
Oh.
So it's just 32 that.
32 feet per second squared.
Oh God! Oh, I popped something. I popped something in my shoulder, Mr. G.
Was it a bad pop?
I did.
Aaron's got poppy bones.
I think I need to go to the hospital.
And the thing about it is, Aaron, you're gonna, at some point, you're gonna be like I am, where pops are just a way of life.
That's my way of life. I go to the
I'm already-
chiropractor
I'm
on
already-
February
told-
1st.
Have I told you yet that my body is a temple?
You have.
Did not.
My
Did
body,
not.
my body is a temple, ancient and crumbling.
Maybe you haven't. That's new.
See? Told you.
I'm
I
sorry.
definitely heard that.
You have heard that? Have you heard that before? About my body being a temple?
The first part of it.
Oh, my body's a temple,
I get to go-
ancient and crumbling.
I get to go to the chiropractor and he's going to yell at me because I have bad hips, really bad hips.
Yeah, well,
He told me I will need hip replacement when I'm old.
yeah, well,
Yeah, I'm just single minded.
I will be a first-hand witness of the same. All right, 32 feet per second squared. So that's zero velocity, constant acceleration. So you pick up 32 feet per second squared. So what do you do to get that?
I don't really know. I'm kind of lost.
Integrate.
Well, right here,
Integrate.
32 feet per second squared, we know we're going to have 32 here, right?
No.
Is that right?
Why?
And then right here, we're going to have, what is this one going to be?
64.
Actually, it's going to be 128.
Ah, I'm confused. I need help. What's going on?
I think, because per second squared. Let me see here. We have, and where does this come from? It comes from someplace. Okay, it comes from position of t, x of t equals negative 16 t squared. So v of t is going to be negative 32 t, and a of t is going to be equal to negative 32. So your acceleration, but this is going to be your velocity. So your velocity is going to be here, negative 32, and this one's going to be,
Wouldn't it just be positive? Because it's 32 feet per second.
negative 64. You're right, it's going to be negative 96, is that right? This is negative 128. Okay?
So I was right about the 64 thing.
Yes, you were right, I was wrong. Because I was thinking, I was being too complicated with the, but that's going to be right. And so we can go look at the other things here. We look at the other things here, and we know this is going to be halfway between, so that's be negative 16. This is going to be halfway between negative 48. And this one's going to be negative, is it 70?
70.
70. No, 80, excuse me, 80, right? Yeah, 80, negative 80. And this will be 112, right?
Yes.
So this is your velocity. Then to determine the total distance traveled, complete the chart to velocity, determine the distance traveled in 4 seconds. What does this not tell you? It doesn't tell you which method to use, right?
Nope.
Which
So you're
method
gonna-
would you use?
I don't know.
Why don't you use a trapezoid on this one?
Okay, is that what I just did?
Why don't you use a trapezoid? Gavin,
Use the trapezoid.
I don't think you need that for your trapezoid, do you?
Use the trapezoid.
I don't think you need a phone for a trapezoid. is what
Oh,
I'm
no, I don't. I did it. I did it.
Was there 8 and
I think it's a trapezoid. Well, that's a parallel.
There are 8.
No. It's two. It's a parallel. Why is 3 and parallel? It's 2. That's really good.
I'll tell you what I'm seeing here, just looking at this thing. Now, what I'm going to do here, I'm going to make an executive decision. I'm going to change this. I'm going to change this to S of t. And S of t is going to be, what's S of t going to be?
The absolute value.
Absolute value of velocity. So I'm going to just change these, just make my life easier, right? Are those numbers going to be easier to work with?
I'm thinking so.
I think so. So what is this going to look like though? Okay, here you have your t, here you have your v of t, and so here you're starting 0, 0, and then here you're at 4 seconds, and you're at 128. What is the relationship between these two?
It's gonna
Increasing.
But increasing like this. So what is going to be your answer?
Oh my goodness, it's a triangle.
Your answer is going to be a triangle.
Triangle.
So what is going to be our distance traveled in those 4 seconds?
It's gonna be 200.
It's gonna be,
Yeah, it's going to be 1/2 of 4 times 128.
256.
Which is going to be 1/2 of 512, which is going to be
200 and
256 feet. Okay, so we could go through and do a trapezoidal sum, but we're going to end up with the same thing here.
But I already did.
Did you get the same thing?
I wrote the blank.
Well, I didn't add them all up.
You didn't add them up, but you would have got it.
Oh well, we're just gonna.
So this is an example where we're seeing what's going on and recognizing this is a geometric shape can help you quite a bit.
Oh, now we're on the question. Trapezoid rule.
Yeah, trapezoidal rule, and we're going to talk more in detail about that tomorrow.
Yeah.
I want to go ahead and shut off the camera and talk a little bit about some class business for Friday.
All right. What's Friday?